So let's go ahead and kind of look at some series and look at the radius and intervals of convergence in their graphs. So we've looked at this series and we saw that it only had the radius of convergence at 0. So the interval of convergence is just a point, and if we looked at that graphically, then it's just that point. We also looked at this one, x to the n, which was the geometric, and we saw that that was radius of convergence was 1 because it converged between -1 and 1. Its interval of convergence is -1 to 1 because we know that at -1 and 1 we have divergence, and so we could graph that and it would not include the endpoints. Okay, we looked at this particular series and we found that the radius of convergence was infinity, so that would be expressed like this, and graphically we would just show the whole line. We didn't look at this series, but we looked at this series shifted by 3. We looked at it with an x minus 3 right here, and so it would have the same radius of convergence. Everything would just be shifted by 3. So our radius of convergence is still 1. When we looked at it shifted by 3, we found the interval of convergence from 2 to 4, including 2. If we slide that back down so that it's centered at 0, our radius of convergence would be from -1 to 1, including the -1, and our graph would look like this. So when they are not centered at 0, we could bring them back to 0 by just taking out that shift. The radius of convergence would be the same, the endpoint convergence would be the same, we just slid this down by 3. Now let's look at another one here. Let's go ahead and apply the ratio test to this. So we have the limit as n goes to infinity of the absolute value of -1 to the n plus 1 x to the n plus 1 over n plus 1, and that is over the nth term, but we'll go ahead and multiply by the reciprocal, so that'd be n over -1 to the n x to the n. So let's see what we can do to simplify this. So this is -1 to the n times -1, and this is x to the n times x. So we can reduce these -1s, we can reduce these x to the n's. So let's see how we can express this. So we have an x here, absolute value, so we're not going to worry about the -1. We're going to bring the absolute value of x out in front of the limit. So then we have the limit as n goes to infinity of, it looks like we've got n over n plus 1. And we were interested in when that is less than 1. We saw this a minute ago. We know that basically we can express this as 1 over 1 plus 1 over n, and so this limit here is 1. So we have that the absolute value of x needs to be less than 1, or we could also express that like this. So we can see that our radius of convergence is going to be 1, and our interval of convergence is going to be -1 and 1. Although we don't know about the endpoints. So now let's test the endpoints. Let's test -1 here. So if we look at this series and we put -1 here and we have n, we put -1 here to the nth over n, we can see that when we combine these, this is -1 to the 2n, this is always going to be positive, and so this is just going to be a 1, and we have the harmonic series, so it is going to diverge at -1, so we will not include -1. Now let's check that out if we put a 1 in. So we have -1 to the n, 1 to the n over n, and again we have harmonic but alternating, which converges, and so we would include this endpoint. So our radius of convergence was 1. We did not include the -1, but we did include the 1. So if we graph that, not included, included. Okay, let's go ahead and look at another one. Here we have a series, and we're going to apply the ratio test so we can determine convergence. So we have the limit as n goes to infinity of the absolute value of x to the n plus 1 over n plus 1 squared, and again taking that over the nth term, so we'll multiply by the reciprocal of the nth term here. Now as we look to see what we can do to simplify this, again we have this x to the n and x, so that's just going to leave x, and the x to the n's will cancel. So let's go ahead and express this, bringing the x out in front of the limit. And then we have n squared over n plus 1 squared. So let's go ahead and multiply numerator and denominator here by 1 over n squared. So that will make that 1. And this would make that 1 plus 1 over n because it's inside of the squared here. And now we let n go to infinity. We can see this limit is 1. So again, we are interested in convergence when this is less than 1. So it is when the absolute value of x is less than 1. So again, we have our interval. Our radius of convergence is 1, and our interval is -1 to 1, but we need to test the endpoints. So first of all, we will look when x is -1. And we see that we have, it doesn't matter if it alternates or not, because if we looked at the absolute value of this, we have a convergent p-series, and so it will converge at -1. And same thing when we put in 1, because we have this convergent p-series. So we include both endpoints. So let's go back, and we know our radius of convergence was 1. Include both endpoints, and so our graph looks like this with both endpoints included. Okay, let's go ahead and look at one last one then. And as we consider this one, let's go ahead and apply the ratio test. So we have the limit as n goes to infinity, absolute value of x to the n plus 1 over 2 to the n plus 1 over the nth term, so multiplying by the nth term's reciprocal. It looks like that. Seeing what we can do to simplify, this will leave x because the x to the n's will cancel. This is 2 to the n times 2, so the 2 to the n's will also cancel. So we have left, bringing the x out in front, limit as n goes to infinity of 1/2, and we're interested in when that is less than 1. So our n's are all out of there, so it doesn't matter when n goes to infinity, we still have the 1/2. And so when the absolute value of x is less than, multiplying both sides by 2, we would have convergence. So looking at our interval of convergence, it's going to be from -2 to 2, but we have to test the endpoints, and we can see our radius of convergence then is 2. Now as we test -2, -2 to the n over 2 to the n, and so we could actually express this as, this will just, if we put them to the n, this is just -1 to the n. And we know that that diverges, so we don't include that endpoint. And if we tried 2, we'd have 2 to the n over 2 to the n, which is just summing up a 1, and that also diverges. So we don't include either endpoint. So as we go back here, our radius of convergence this time was 2. Our interval of convergence then was from -2 to 2, but not including either endpoint.